Hi folks, so this is a follow-up to the previous video where we were looking at trying to install Google Colab for the sake of using this program, which is CPET analysis. So first thing to mention is that this is not a program as such. You haven't installed anything on your computer. You're just running Google Colab on a Google server. So there's no particular requirements for the computer. It just operates in a web browser. What you do need is internet access to be able to run it. So this is just a little project that I worked on. It's just a Python program that's running in Colab. So this is copyright me, but that doesn't mean that folk can't use it. I would encourage everyone to feel free to distribute it, to share it with other people. It's just not to be used for commercial purposes. And if you're going to use it, please credit me for creating it in the first place. You're welcome to look at the code if you're interested in that kind of thing. And adapt it and change it again, just as long as you credit the author, then that would be appreciated. So how we go about using this is fairly straightforward. Once you've opened it in your Google Drive and it pops open in Collaboratory, then it will open up looking roughly like this. Now, the way it works is it goes and looks at some CPET data, breath by breath data that I have stored, and then it runs sections of code on that data to allow you to do different things with that data. So the thing that makes it a little bit complicated or a little bit fiddly is that you have to run each section of code one at a time, do what's in that section of code, and then move on to the next section. So you always have to remember to hit this little play button. It doesn't always appear. Sometimes once you've run it before, this will kind of disappear. When you mouse over it, then you'll find that button to push again. Okay, so that's really what you're going to see is that these different sections will pop up, and what you want to do is click on that button, and that will run a little bit of code. If you're really interested in, you can click show code, and that will show you what I'm up to in the background. If you accidentally do that, then you just click on that section, you go to view, and you click hide code, and that disappears the code again, and you get to see something a bit prettier. So what you're going to do in any given section is follow the instructions or what you're being asked to do in that section. So here what we're going to do is we're going to pick a different example. So I quite like example 3 because it's a very simple and nice quality example to work with. And if you choose to, feel free to put your name in here. It's not necessary. This is more for a version of this code that I use when I'm doing a presentation, and a lot of people are playing with the same program. It allows me to compare everybody's results together and look at things like concordance. How well does everybody pick the same number? What's the variance? And that is a useful teaching tool. But don't feel like you have to put your name in there. It's just, if you choose to do that. So I'm not going to spend much time on the physiology and the rationale behind what we do when we analyze a CPET. That's for other videos and for courses that I talk on. What we're just going to talk about is how you use this program to help you look at that data, produce a report that's useful that can then be interpreted. So we're not going to talk too much about the details here. Suffice to say, what we'll do is we'll have a little look at the peak values. And then in a normal test, you would look at all the different peak values. We're going to look at a few examples. That's all we'll do with this program. We'll look at excluding data above respiratory compensation point, ventilatory threshold 2, for the sake of making it easier to identify VT1. We'll then go on and identify VT1. We'll look at the different slopes and measure those. In a normal exercise test, you would then go and look at things like the intra-breath measurements, the exercise oscillated ventilation, and you might also look at things like the invasive blood gases. We don't have the facility for those last few sections yet on this program. It's something I'm working on, but I'm not there yet. So we will skip those bits in this demonstration. And then finally, you're going to produce a report. That's a graphical output, the standard 9 panel, and a tabular bit of data to look at as well. So this is on the next section. Okay, so we're going to look at verifying peak values, and we've got this little graphic that's saying push this button, and you can see that button has appeared to have disappeared. If we mouse over that number, that's section 5, then that lets me run the code, and suddenly we get some graphs to look at. This section is just about using these sliders to try and pick the peak values. Okay, you can see again it's a slightly clunky code because it redraws the line after I've moved that slider. You can see I've overcooked a little bit here. I'm taking a value that's sitting there at about 2 litres. And if I look at this graph, the peak VO2 is closer to kind of 2,200. So we're just going to bring that back a little fraction. And it is a little fiddly because it redraws itself every so often. And we'll see what we can get. But it's really about a sanity check of the data that you're looking at. And remember that when you're looking at peak VO2, you're looking at the last, say, 30 seconds of the test. So do the same thing for ventilation. We're going to bring that to roughly the same point to speed things up. But you can see I'm under reading a little bit. When I look at that graph, it should be above 80. So I need to bring this forward a few. And it is a little fiddly, I've got to be honest, until we're getting something sensible above 80 litres per minute. And you can be more pernickety if you want to be. That's okay. But this is really just about trying to encourage you to look at the peak values, not take what a machine tells you is the peak value. Look at the graph, look what you expect it to do, and then you specify in your report what that peak value is. So we can do the same with heart rate. We're now kind of just labelling the obvious. And we're checking that we're somewhere above 220. There's my peak heart rate, 124, so that's good, that works. Let's pull the oxygen pulse up to here and then have a look. So I have a bit of an outlier, so I hope it's not landing on that, and I shouldn't be above 18 mils per beat. Should be more around about the 17s, and I'm about 17.6, so I feel comfortable with that. And then there are things like peak wattage, which a system should have no problem picking out what the peak wattage is. But again, just for careful and thorough analysis, you should just double check that what you're seeing matches with what you're seeing on a report. So that's just on the p-values, and you can do that for a number of different other variables as well. Moving on to the next section. So again, I'm looking for a little button to push here. Now, this one's a little bit glitchy sometimes and doesn't draw in the right way. So if it's not drawing in a nice square like that, then just hit the play button again, and it will draw it appropriately. So what we're looking for here is to exclude the data above the second ventilatory threshold. Now, I'm not going to go too much into the physiology behind that or at all, but suffice to say that you can use this graph to shift this slider, and the stuff that is grey is the stuff that will be excluded in the subsequent analysis that we're going to do. So I'm going to bring that up to very roughly about there and say this is a nice straight line, and then it's deflecting upwards around about VT2. Okay, and that's all I really need to do is just exclude that data and the recovery data so that in the next analysis, we're just looking at that straight line. Good. Again, on to the next section, go looking for that little button. Mouse over, here we go. So we're going to try and find AT. Now, sometimes you'll find that when you click on that, the next section jumps up a lot. If it does that, then just recenter it and click on that play button again. The other thing to be aware of is that you can pinch and zoom with this just to make your life a little bit easier depending on how you're finding the scale of this. And you can do that on the browser as well in terms of how much you're zooming in and out of the code. So what we're doing is trying to pick AT with this graph. And we can just do this by eyeball. Again, we're not going to talk about the physiology, but the AT is this deflection here in what's called the V-slope. The CO2 versus VO2. And that deflection there is very, very clear in this example. It's why I use example 3 as a starter for 10. And so here around about is our AT, our VT1. So let's just pull that in a little bit until it's over. Again, it's just doing that annoying redraw, which is a little bit distracting. Sometimes it will do it a bit more smoothly. And what you can see is we've got something approaching where we think our VT1 is. Lovely. Now, that's all very well in a very easy example like this. Sometimes it's not as easy, and so it's better to use other techniques to try and identify AT. So one of the ways we can do that is with the lines of identity. So the line of identity is just a straight line running at 45 degrees when this is appropriately scaled on a 1-to-1 ratio, but running it at 45 degrees and basically going straight through the origin. And this is effectively an RER of 1. So you can see that a VO2 of 1 equals a CO2 of 1, 500 to 500, 1500 to 1500. So the ratio between oxygen and CO2 is 1 on that line throughout. Now what we can do with this particular technique is we can drop that, we can change the offset by pulling that 45-degree line across, and then we can bring it back up towards the data. We don't have to bring it very far up in this case. And where it starts to touch this response, because this slope is less than 1 and this slope is greater than 1, because this is a slope of exactly 1, then it should be touching that response at round about the AT. So we can put in our VT1 again just to confirm that kind of agrees. This is where we're generally touching that data for the first time, and that does tend to confirm that we're in the right place. The other way we can do it is by using the modified V-slope way of doing things, and we're looking for the crossover point between the two linear sections of this response. So what we do is we use these sliders. This first one is the lower slope and this one is the upper slope, and we can decide what data we want to use to draw a best fit line for this section and a best fit line for this section and find out where they cross over. So I've kind of already sneakily put in my AT over here. You can see it just up here. So what I'm going to do is bring that data up and just cross over ever so slightly. And that gives me a reasonably good straight line approximation for that initial response, with our AT probably being right about here. Let's put it a little bit further. You probably shouldn't do this because it starts to take some of the data from the other side of AT, but it's a nice illustration. And then we can do the same with the upper portion. We bring that down and you can see this is giving a nice best fit of this upper portion. And there's a bit where these two lines meet and cross over. And this should be your AT. Again, let's put the VT1 back in again. And we can see that confirms quite nicely that we're in the right place. It's crossing over there. This is where that line of identity is coming in, and it's where we initially thought we had a deflection anyway. So very easy example, I know, but it shows you how you use the tool, and that's the important thing. So once I've done that, I have selected AT for subsequent analysis on this. Okay, so let's scroll down to the next section. So we found the AT. Let's just find this button again underneath that number, run it, and here we go. These are other ways for looking at the AT. You can look at the RER, we can look at the end tidals, we can look at the equivalence, and this is the V-slope again. Now, if I'm not happy that I'm in the right place, I can look at these other graphs. So here you see the equivalent for oxygen is rising. This is the blue curve, is rising from AT, and that's what we would expect to see. The end tidal is rising from AT, and that's what we would expect to see. And the RER is rising from AT. So this tells us quite nicely that we're in the right place. Again, given how good an example it is, that's not really a shock. But you can then move that around if you disagree with yourself a little bit. Okay, let's move on to the next section. Again, I'm looking for that little play button. So here we're just picking the slopes. So this involves putting in a best fit line and deciding what data you want to select and what not to select. Again, that's a topic for another day, but this is just showing you how you decide which data points you want to use. And then this will draw a best fit line and give you a slope, and that's 10.2. That's quite close to where I would expect it to be, around about 10.3 mils per minute per watt. We can do the next section, which is the Harry VO2 slope. And again, it's the same process. Put in that best fit line and then choose which data points you want to use to structure or measure that best fit line. And here we're getting about 40 beats per mil per minute of VO2 consumption. And that's what you would expect for an average adult male. You can look at the slopes for gas exchange efficiency. So again, same process, put that best fit line in and then select the data points you want to use. Again, we've excluded the data above the second ventilated threshold. And again, we're trying to find a best fit line for here. And that's about 27. And again, that's where I would kind of expect a normal gas exchange efficiency to be. So as we discussed, you can also look at things like exercise oscillated ventilation, looking for oscillations in the ventilated pattern, but we don't have that facility yet. You can look at the blood gases, you can look at the intra-breath, but we're not going to do any of that with this particular version of the program. So now that we've done all the analysis, we've quality control of the data we're going to pick, now we're going to create a report. So let's again find that little button to push. And this then creates a 9-panel plot that you will be familiar with, or you will become familiar with as you start to get into analysing cardiopulmonary exercise test data. So this is a kind of standard layout 9-panel with our AT. highlighted in the relevant graphs. And then we can also create a tabular report. So again, let's go looking for this. And so here what you can see is we've got some data that's gone in, and this data here has come in from the analysis above. So again, you can see that peak VO2 at around about 2 litres that we've selected, that peak ventilation around about 80 litres. This is all data points that we've quality controlled already. What we need to do is then put in the appropriate demographics because we want it to calculate. And what you can see is we automatically get changes the minute we've changed the demographics. So this isn't a specific patient, I'm just guessing at the demographics. But you can see that once we put that in, we get a change here, and that tells us what our upper and lower limit is and what the percent predicted is. Change the age of the patient as well. Super. And once you've done that, you're finished. You have created and analysed a CPET, and you're ready to take those two outputs, the tabular report and the graphical report, and start to interpret that data. Once you finish that, then what you can do is scroll all the way back to the top, or if you want to notice there's a table of contents, you can actually flip to any part of that analysis again if you want to have a look at it again. But you can go all the way back to the top. We can run that code again, change the example, and then when we run that code again, it may or may not be obvious that we are looking at a different test now. So you can see the peak per output, instead of being 142, and the last example is only 100. So now we have a different set of data to go looking at. But again, you've got to remember that you're clicking on this little play button each time you go down through a new section to make sure that it reanalyzes that data. It takes the data from above and works its way down. So you can work your way through all of that until you get to the bottom and you create now a new report and a new table that allows you to do the interpretation. And there are 6 examples to play with currently.